let's talk a little bit about IPMVP. IPMVP first, as mentioned before, it defines the standard and transparent approach. It's a transparent approach for measuring savings. The MMV framework, IPMVP and ASHRAE Guideline 14, they establish standardized method to calculate energy savings, right, in a consistent, repeatable, and way, right? This ensures savings are real and can be verified, which is important for stakeholders such as building owners, utility companies, and government incentive programs. Now, when we have project and we want to do the MMV, the measurement and verification, they usually a trade-off, right, between cost and accuracy. So balancing the measurement accuracy and cost is very important. MMV involves a trade-off between accuracy and cost. No measurement and verification, or no extra cost. There's no dedicated measurement beyond utility bills or existing data. It's lower cost, but there's a higher uncertainty in reported savings. We can assume there will be a savings, but if it's not verified, then there is an uncertainty. It may be acceptable for simple projects with predictable savings, such as lighting upgrades. If we switch incandescent light bulb to LED, then we know it's going to save some energies. So that maybe we don't need that extra cost. Now, for 4MV, higher cost but maximize savings, right? 4MV uses meters, sensors, advanced statistical analysis. It ensures persistent savings and validates performance of energy saving measures. It's often, the 4MV is often required when saving guarantees or financial incentive depends on the measure result. Okay, depend on measure result. So higher cost, but you have the guarantees. How do we choose which one is the right approach? Well, smaller projects, then there may not be a MMV necessary or limited MMV, right? Low cost, estimated savings. But larger, complex projects, more detailed MMV can be justified, right? Because more detailed MMV ensures reliable and long-term savings. Guarantee the performance contract, right? So something called guarantee performance contract. 4MV ensures savings, right? The choice depends on the project scale, cost, and the need for accuracy. Performance guaranteed. How does this work? Measuring and guaranteeing savings before a project is completed is done through a combination of, for example, the baseline measurement, engineering model, and statistical adjustment, as well as performance contract. So let's talk a little bit about the process. So establishing the baseline before the project, right? Before the project. Before implementing an energy saving measures, MMV professionals will measure and analyze the current energy use. And that can include historical energy data like utility bills, interval meter data. Also, operational conditions, equipment runtime, occupancy level, the weather conditions, right? And system performance, like HVAC load, lighting levels, motor efficiencies. Right? The goal is to create a baseline energy consumption model that can represent how much energy would have been used if no project was implemented. Okay. Then predict the savings. That's also before the project. We need to predict the savings. Engineers can use simulation models or equipment specifications and real world test data like rescreen. We have data from rescreen as well to estimate how much energy a new system will save. For example, a new high efficiency boiler, right, has a known thermal efficiency that can go higher than 95% versus 80% conventional boilers. Right? Also, a lighting retrofit with LED fixtures has manufacturer rated wattage. You can see how many watts per LED luminaires. Right? Building automation upgrades as well reduce unnecessary HVAC runtimes based on the more advanced control logic. So advanced energy modeling softwares like eQuest, Energy Path, in Energy Plus, or regression analysis is often used to simulate energy savings under different scenarios. Okay, number 3 here, adjustment for real world conditions. That's after the project. So once the project is complete, actual energy consumption is measured. We can measure after the energy project completed. Since external factors change, the weather change, the number of occupancy can change, in a factory production level can change. So there are many factors that can change. Adjustments are necessary. So if a factory produces more after a project upgrade, right, the total energy may go up, but savings per unit of production can still be valid. Or if a winter was warmer than usual, heating demand is lower, so savings must be normalized for typical weather. Okay, and so we'll talk about IPMVP options A, B, C, D, right? So let's say if we use option C, the whole facility, or option B, retrofit isolations. Again, we will talk about those options later. And then the adjustment for these factors ensures savings calculation reflect the real performance improvement. Okay. Saving guarantees by performance contract. So there are performance contract in energy performance contract, the EPCs, right? EPCs. Savings are guaranteed by project providers. Okay, project providers. If measured savings fall short of projections after the adjustment, right? After the adjustment, then the provider must pay the difference because it's a performance contract guaranteed. This is why accurate baseline, right? Accurate baseline and adjustment are very important. They are crucial both for the customer and the project providers. Well, why is performance guarantees important? Why this matters? Let's look at this example here. A customer, maybe a college has, now it's might be a bit too small It's a bit too small for me to read, so I'm going to read from my screen. 10,000 fluorescent luminaires consuming 4 million kilowatt hour annually. Assume, let's say, the college spend 400,000 per year, assuming the energy cost 10 cents per kilowatt hour. Okay. A project provider, what we call energy service, sometimes energy savings company, depending on it can be both, right? So ESCO, they propose to replace all the luminaires with LED, expecting to save about 50%, and that would be 200,000 of savings, right, for the energy use. Now, the project cost is going to cost $1 million. The contract agreement between the provider and the college. Well, the provider will install all the LED luminaires and guarantee that at least 1.8 million kilowatt hour will be saved per year, right? Per year. Now, after the project, there's MNV, right? MNV procedures. After the adjustment for occupant behaviors, there could be a behavior change due to the upgrade. There could be a weather change, maybe more cloudy days or more sunny days, depends. And as well as the change in facility operations. So we have to have some adjustment, right, to the baseline. Now, if a saving falls short, say the actual saving is 1.6 million kilowatt hour after the adjustment, then that's 0.2 million kilowatt hour difference. So the ESCO will pay the difference. Okay. So how much does the project provider pays the college due to the shortfall here? Let's do a quick calculation. So 0.2 million kilowatt hour, 0.2 million kilowatt hour. How much do the provider have to pay? Or multiply the cost per kilowatt hour, right? And I'm sure you can do this calculation here. If we do that, kilowatt hour, so the cost would be 0.2, that would be 20,000 dollars. 20,000. So check my calculation there. Okay. So based on the contract and based on the MNV procedures with the baseline, the adjustment, and the difference, the contract provider, the project provider will pay the college 20,000. Next, what are the purpose of MNV? Let's go a little bit deeper here. Well, increase energy savings. How is that? MNV helps identify whether a project is achieving the expected energy savings. If a savings are lower than expected, like the example, MNV can reveal operational issues, maybe incorrect sensors, like the settings in the sensors, or poor maintenance, like the different factors that can cause the different energy savings. and allow for corrective actions. Document financial transactions. MMV provides transparent, verifiable data to confirm actual savings. This is essential for contract where payment depend on measured performance, right? Like the example we saw just now. Enhance financing for efficiency projects. Investors or lenders they require guarantees or proof that an efficiency project will deliver real savings. It's important, right? Reliable MMV builds trust in energy efficiency projects and make it easier to secure finance. Then, improve design, operation, and maintenance. MMV can highlight issues like overventilation in HVAC system or lighting controls not functioning properly. It helps optimize future designs and ensures ongoing operational efficiency. Okay. Also account for variance from utility budget. Organizations rely on estimates utility cost for budgeting. Right? MMV helps explain the unexpected increase or decrease in energy bills. For example, a new process increase energy demand if there's a change in the process. Enhance value of emission credit. Well, many energy efficiency projects reduce greenhouse gas emissions, right? MMV provides verified data on energy reductions, which is necessary for carbon credit program. Then the increase energy awareness of facility users. When MMV report shows actual savings, staff and occupant becomes more engaged in because if I know I'm contribute to energy savings, I'm more engaged in energy conservation behaviors. For example, if MMV shows energy waste if there's any waste during the off hours, right? Employees may be more encouraged to turn off equipment when not in use. Finally, get the lead point. Lead the awards point for verified energy savings. MMV provides the documentation needed to qualify for this point under the LEED certification program. So MMV, and that's the measurement. The M stands for measurement. It does not mean continuous monitoring though. Instead, it focuses on measuring energy use before and after an energy conservation measured to determine savings. So why can we measure savings directly? Right? Why can we measure savings directly? Well, so they are the difference between two scenarios. Savings, right? Savings are reductions, and it's the difference between two scenarios. What actually happened and what would have happened. So what actually happened is the measure energy use after ECM implementation. And what would have happened if no ECM was implemented? That's the baseline energy use, adjusted for external factors. Okay. So we measure energy use. for different scenarios. Since the second scenario, the avoided energy use does not physically exist, it cannot be directly measured. So it must be estimated using the MMV. Right? Now, how are savings determined? We talk about the difference between two scenarios. Right? The measure energy consumptions like kilowatt hour, BTUs, before and after ECM implementations, or adjust for external factors, weather, occupancy, production level, etc. and etc. Use statistical engineering analysis method to calculate the difference, right? And this distinction is critical in MMV. We don't measure savings again. We measure energy use and analyze the difference.